Hello, digital artists. Welcome to a new tutorial.
In this video, I will show the process of creating a parrot, specifically a yellow-headed Amazon. According to the project plan, I needed to create a realistic parrot in one pose for high-resolution rendering. How I solved the rendering problem can be seen in the previous video. Additionally, I needed to animate the parrot, but not entirely, only the head and eyes, and partially the body. However, it should not spread its wings. Therefore, I created the parrot model in a static pose with folded wings. Later, I created a simple rig and animated the parrot. It was also expected that the parrot would have dynamic feathers during the animation. So, let's get started. First, I of course reviewed photos of the yellow-headed Amazon to learn its characteristics and how it differs from other parrot species. I looked at its proportions and coloration. I determined what body position is natural for it. It was also important for me to find good references that I would use for creation. After I had about 15 photos from different angles, I could start sculpting. To create the general shape, I prefer to use Dynamesh and ZBrush. You can also use Sculptress, which is perhaps a more convenient tool. However, for my needs, Dynamesh was sufficient. So, I proceeded to create the general shape. The working method should always be from general to detail. I stretched the neck, for more intense smoothing, which is very difficult when you're using Dynamesh, you can use the Smooth Stronger brush. With moderate Dynamesh resolution, Smooth Stronger brush works just wonderfully. Now it's time to start creating the head and beak. For sharp angles using the Move brush, you can use the AccuCurve. This is a very good tool for creating a sharp beak, for example. Using the Dam Stand-Up brush, you can define the boundaries of the beak and split it down the middle, creating the parrot's mouth. Then I created the thickening on the nose. The hole in the nose, and the indentation for the eyes. The wings on this model should be in a folded position. So, I made them pressed against the body. Of course, you need to create the legs as well. And ensure the wings are on the sides of the legs and not intersecting them. Then I tried to form the overall standard pose for the parrot. To visualize how it will look with feathers, I created temporary feathers on the tail. I'm satisfied with the general shape at this stage. When the overall model from Dynamesh was ready, it was necessary to start creating the low polygon model, which can then be used for texturing and animation. For this, I can now leave only the main body that will be under the feathers. At this stage, it's not important for me to create the final model. I'm only interested in the shape that I will use for creating the low poly version. So, let's start creating the low poly model. In ZBrush, there is a good tool for this, the ZBrush. There are too many polygons. I prefer the main model to be highly optimized. The result is not always perfect, so it is necessary to refine or change the model created by the ZBrush. For this, I export the low poly model to Maya. But I will also need the high poly model of the Parrot that I sculpted. I exported the necessary models, and now I need to import them into Maya. Both the low poly and high poly models. I will use the high poly model as a reference and adjust the topology of the low poly model where needed. I select the high poly model and set it as a live object. Now, the polygons I create will be placed on its surface. For topology, I use the Quad Draw tool and enable symmetry. I won't explain every step here, assuming you're familiar with the basics of topology in Maya. It was important for me to create a topology that provides a nice distribution of polygons and is convenient for animation, as I will later need to animate the eyes and head. Now you can see the result that I ultimately achieved. To create textures, it's necessary to create UV mapping. Here, you see the result. I hope those watching this video are also familiar with creating UV maps. So, to create details such as wrinkles around the eyes and the beak structure, I send the Parrot model with good topology and UV coordinates back to ZBrush. I increase the model's resolution and start sculpting the details. Let's begin with the beak. The beak structure will be covered with small cracks, which can be easily created using an alpha map. Of course, you can use your tools and textures. I manually sculpted the wrinkles around the eyes. The main principle is to first sculpt the raised wrinkles using the clay buildup or standard brush. Then, using the dam standard brush, carve the indentations between the folds. Once this is done, use the inflate brush or the inflate modifier to puff up the wrinkles. If you need even more details, you can use a fine skin texture as an alpha. For creating the bump on the nose and the nostril, I used a similar principle. Here, you can see the final result of the wrinkles around the eyes and the beak. I had to put more effort into the details on the feet. To create the scales, I used a mask and the move brush to pull out the shape. There were also many layers with different alpha textures. Since this lesson is not about sculpting, I will skip the explanation of creating the parrot's feet. When all the necessary details were finished, I started creating the texture. For this, I exported the final low poly model and the high poly model with all the details Substance Painter. Using the texture baking procedure, I transferred details from the high poly model to the low poly model. Here you can see the textures on the parrot's feet. For the color texture, I created a base beige color for the feet, adding variations with different brushes on separate layers. I also highlighted the raised skin and scale details using the ambient occlusion generator. For the parrot's body texture, I essentially followed the same process. I first baked all the details from the high poly model onto the low poly model. The main color texture was painted manually. Here you can see all the layers. I started with the base green color, then added the color for the beak, which I separated using a mask. I then added color variations. Using the generator, I highlighted the details and added shadow layers inside the beak and nostrils. The generator was also used to add details to the skin around the eyes. Shadow layers from the feathers were added, as the skin underneath them needs to be darker. The remaining layers and masks were related to roughness and specular. The beak should be shinier than the skin around the eyes. After I finished creating the textures, I exported them. After importing all the textures and models of the body and paws, I created the materials. This is the final model we will use for feather creation. And, of course, I created the parrot's eyes. The eyes consist of spheres where the iris is a separate object. As you can see, I created small feathers around the parrot's main body. These feathers mostly have the same shape with random distribution, and the only differences are in their length, width, and texture. The wings and tail, however, are made up of larger feathers that are arranged in an orderly manner. Here I created each type of feather manually, and then manually placed them on the wings and tail. We won't focus on those now. Let's concentrate on creating the small feathers around the body. I also created a blend shape for the parrot's body in case we need to adjust the shape after distributing the feathers. Since the parrot doesn't have feathers yet, it's hard to predict what its shape will be with the feathers. Having a blend shape allows me to easily adjust the head size, chest width, and so on after applying the feathers. I also have the original low poly model in the scene, which can be used for initial skinning. This low poly model can then be used to transfer the skinning to the high poly parrot body model. So, let's get started on creating the parrot feathers. I create a copy of the main body. I prefer to create grooming on a separate model to have more control and organization in the scene. It's also often advisable to remove polygons where no hair is present to optimize and speed up the subsequent animation. I will create the feathers using interactive grooming. Open the interactive groom editor. To do this, go to the Generate menu and select Interactive Groom Editor. If it's not there, you need to activate the XGen plugin in the Windows menu under Settings, Plugin Manager. To create the grooming, I select the model. Then in the Groom Editor, I press Select Interactive Groom Splines. I name my new groom and press Create. In the base settings of our groom, I can reduce the density so that a large number of hairs doesn't slow down the computer during work. When the feathers are ready, it will be clearer how many feathers we need. To ease the modification of our future feathers, I create a guide modifier. In the Attribute Editor, by pressing the Create button in the Guide section, Maya generates random guides. Let's go ahead and remove the hair from the areas where it shouldn't be. Ideally, this can be done right after creating the grooming, and then we can create the guides for better clarity. But from a process standpoint, it doesn't really matter. To leave only the desired hair on the model, select the grooming base and create a mask in the density mask. We can either use an existing texture or draw it ourselves directly on the model using the Paint tool. Click on the brush icon. Locate the folder where you want to save the hair textures in the file path, and name your texture. Then, select the resolution, which determines how sharp the hairline will be. In this case, we need a soft edge. Next, choose the initial color of the texture. White means that everything will be covered with hair, while black means there will be no hair. I choose black, so I can manually draw the areas that will be covered with hair. Click Create. As you can see, all the hair has disappeared. Then, in the Paint tool settings, I enable symmetry along the x-axis so that the hair is evenly distributed on both the right and left sides. I select white for the brush color and start painting. For better performance, I temporarily turn off hair display. I fill in the body area where the small feather should be with white. I'll leave the lower part of where the legs will be, as well as the areas where the wings and tail will be, in black. And of course, the beak should be completely black. After finishing, I can turn the hair display back on. As you can see, there is some error, and not all the hair is displayed. In such a case, I recommend simply saving the scene and reopening it. As you can see, after reopening the scene, all the hair is in the correct place. So, let's continue with our guides and feather shaping. It's very important to select the sculpting layer in the Guides tab for guide modification and activate it by pressing Edit. Then, after selecting Guide Base, we'll erase all the guides and create our own. To do this, select Guide Base in the Attribute Editor, press the Density brush, choose the Paint Operation Decrease, and click Flood. Now we've erased all the guides that Maya created. To create our own, we need to use the Place Brush tool. Enable symmetry along the x-axis and start placing the guides. We don't need to create as many as Maya did. However, to have more precise control over the shape, it's better to create more guides on the head. On the body, we only need a few guides. If we don't need any guides, we can easily erase them by using the same brush while holding the Control key. With the guides, we can change the direction and length of all the hair. Using the comb brush, you can now easily shape the feathers by combing the guides. Our feathers are too short. Using the length brush, you can increase their length. By clicking Flood, you increase the length of all the guides at once. With the cut brush, you can easily trim the feathers if they're too long. Don't forget to enable symmetry. You can cut guides and hair as needed. But after finishing, it's recommended to use the rebuild function, which redistributes all the vertices evenly along the curve. We can see that the hair is controlled by the guides without any issues. I also need to remove the hair from the eye area. To do this, I click on the brush icon in the density mask and paint the eye area black. Let's continue creating guides on other parts of the body. As the number of guides increases, it becomes more difficult to modify them without affecting the neighboring guides. For this, you can use the freeze brush. You can also enable symmetry on it. I increase the length of the new guides on the body and shape them with the comb brush. Our feathers are already taking shape, and our parrot is starting to look less plucked. Let's continue placing the new guides. The hair on the body is increasingly taking the correct direction. The guides near the beak and eyes are very important. We need to direct them so that the feathers curve around the eyes. Now, we need more guides on the neck and the sides of the body. Let's adjust their length and direction correctly. Everything looks good, so we can continue. The client wanted the feathers on the neck not to lie too close to the body. We'll consider this when creating the guides. On the wings, the guide should curve around them so that the feathers lay nicely and blend with the larger, longer wing feathers. We need more guides on the legs. Here, hair penetrates into the leg model. It's better now, but still not perfect. We'll try to fix this. We also need guides on the side. Let's add another guide. Let's add another guide. It's almost perfect. Now we need to shorten the hair on the tail so that it doesn't stick out as much. Let's refine the shape of the head. Done. This stage is essentially complete, and we can now start preparing to transform the hair into feathers. Save the scene. By increasing the thickness of the hair with the width scale, we can simulate how the feathers will look. Of course, not all feathers can be the same width. The feathers on the head are not only shorter, but also thinner. On the chest, on the other hand, they are wider. We've already set the correct feather length using the guides, but now we need to adjust the width. However, it's not just the width that differentiates the feathers on the head and chest. The density is also different. We used a texture for density that consists of only two colors, black and white. This allowed us to remove the hair from the areas where the wings and beak are located. But that's not enough. We need to distribute the feathers so that there are fewer and wider feathers on the chest, while on the head, they should be thinner, meaning there should be more of them. By strategically distributing the feathers, we can also lighten our model, making it more suitable for feather dynamic simulation. So, how can we achieve this? Let's start with density. To make it look nice and even, we need to combine two textures. The texture we drew and a gradient texture that will gradually distribute the narrow width of the feathers from the head to the wider chest, and then narrow again towards the legs. First, we'll set aside the density texture we created and disconnect it from the grooming. Now, the number of hairs is even across the entire body. Let's now use the ramp texture instead of our texture for density. Choose a smooth transition. As you can see, the ramp controls the density of the grooming. Find the middle color that corresponds to the number of feathers we want on the chest. The feathers look strange. They should look like simple planes. Let's go to the hair width settings and reset the width ramp to default settings. Now the hairs look like simple planes, just what we need. Adjust the density using the ramp color. As you can see, the UV layout I created was not for nothing. The entire body is essentially laid out lengthwise. This makes it easy for me to control the feather properties across the entire body using the ramp. The right side of the ramp corresponds to the head coordinates, where we need more feathers, so we create a lighter color there. Now let's adjust the feather width on the head so that we can see what density we need there. The left side of the ramp corresponds to the legs where the feathers aren't as narrow, so we can set a lower density than on the head, but still more than on the chest. Done. Now, we need to create an image texture from this texture. For this, I create another ramp texture. Remove everything unnecessary. And place the ramp controlling density in the single color slot of the new ramp. This ramp will be the texture we'll bake. Of course, you don't have to create it, but I wanted the baking texture to be separate. If you go to the Hypershade, Edit, Test Texture, you can set the texture size you want. I set it to 1024 and check by clicking Test Texture. Now we need to combine the two textures. The one we originally painted and the new ramp. To do this, we take our painted density texture and place it in the color gain slot of the ramp. This effectively layers the two textures in multiply mode. In our final ramp texture, We now see a mix of the two textures. Click Test Texture to create a single image texture that combines both textures, and which we'll use to control the feather density. Save this texture. Next, in the density settings, add our new texture. Everything is working correctly. Now we have more feathers on the head, fewer on the chest, and more again on the legs, with a smooth distribution of feathers. Let's apply the same principle to create the width texture. Add a ramp texture to the width slot. We can see how the ramp controls the feather width. Make the necessary adjustments. The widest feathers on the chest, slightly narrower on the legs, and narrowest on the head. Now take the ramp we created and insert it into a new ramp. Using the Test Texture command, create an image texture. Save it. Add the newly created texture to the width slot. Everything looks correct. Now let's move on to the final adjustments. Since we now have image textures everywhere, we can use the Paint tool to modify the feather width and density. For example, near the beak, the feathers should be much narrower. To fix this, click on the brush icon next to the width settings. Check if symmetry is enabled in the Paint tool, and start painting. Darker colors make the feathers narrower, while lighter colors make them wider. Choose the appropriate color and start painting. By reducing the opacity, you can gradually adjust the feather width. Let's narrow the feathers around the beak. And then around the eyes. However, the feathers in these areas are still too long. To adjust the length, we need a sculpt layer. Create a sculpt modifier and click Edit. Select the length brush. Activate symmetry along the x-axis. And start adjusting the length of the necessary feathers. By holding down the Control key, you can change the brush's direction to make the feathers longer again. Let's refine the width of individual feathers again. As you can see, there are few feathers between the beak and the eyes. We need to increase their number. Select the base of our feathers and activate the place brush. Now we can easily add new feathers. Just don't forget to enable the interpolate command so that the new feathers will adjust to the ones already created. By holding the Control key, you can erase the feathers you've created. Let's refine the feathers further to achieve a more precise and aesthetically pleasing result. To introduce some randomness into the feathers, we'll add a noise modifier. After making the necessary adjustments, ensure the noise isn't too strong, just enough to create a slight random rotation of the feathers. The feathers on the chest are still a bit narrow. We need to increase the width of all the feathers at once. To do this, I'll adjust the width ramp value in the primary attributes of the grooming settings. Here you can see the final grooming I've created for the parrot's feathers. And how the final guides look. Now I'll show you how to convert the grooming into polygons. First, select your main grooming and disable the face camera option in the primary attributes. Now, your planes won't automatically face the camera, and you can see that they're oriented in different directions. Using the twist brush and the Align to Surface option in the tool settings, press Flood to align all the planes to the body, as real parrot feathers would be. Next, select the Feather Grooming and, in the Generate menu, choose Convert Interactive Groom to Polygons. Check the settings I'm using. I've enabled Combine Mesh, and it's crucial to activate UV coordinate creation. Click Convert. Once the grooming is hidden, you'll see the feathers as polygons. You can now modify them like any other polygon. Delete, move, resize, or reshape as needed. What's also quite useful is that each feather now has a clean UV layout, and it's available in 4 variations, which is great for creating random feather appearances. I'm selecting the first group of UV coordinates. It was tricky to select them cleanly due to the mirror object setting being enabled on the x-axis, which I'll need to disable. Now, as you can see, I can easily select each UV group individually. Select the first group using Select Shell, then normalize it with the Normalize command and move it exactly 1 unit over. This will make it easier to select each feather group in the future. We'll distribute all the feathers' UVs horizontally, allowing us to use 4 different textures applied randomly across all the feathers. This will give the feathers a natural variation in color and shape. Now it's time to create the feather textures. Let's start by creating a new scene in Maya. Next, create a cube that will serve as the base for our feather. Working with a cube is simpler since it has only 4 faces, which can later be easily smoothed by applying a smoothing operation. We'll add more subdivisions to ensure each polygon has roughly equal sides. Now, we need to create UV coordinates and arrange them on the same plane. First, move the top and bottom polygons to the side. Connect the entire UV layout into a single island. Since we'll be working with a ramp again, now position the top and bottom polygons at the top and bottom of the UV layout. Delete the history, and here's what our UV coordinates look like. Next, open the interactive Groom editor. Select only the polygons from which the feather strands will grow, leaving the top polygon untouched. Create a new groom by going to Create Interactive Groom Splines. You'll notice the strands are pointing in all directions, which is not what we want. So, in the base of our groom, place a ramp in the density mask and set the interpolation to none. This will give us a sharp transition and precise control over the area where the strands will grow. Create the desired colors and adjust the sliders until the strands grow in a narrow strip on one side of the stem. Then adjust the ramp so that the strands also grow in a narrow strip on the opposite side of the stem. Press the 3 button to smooth the stem, and you'll see that it's still a bit too thick. Use scale to make it narrower. Now, let's create the guides. In the Edit modifier, select Guides and make sure to activate the Sculpt layer for the guides. Choose Guide Base and click on the Density brush. Use the Flood option to erase all the guides. Turn off the groom visibility to avoid any distractions. And use the Place brush to create our guides. Be sure to enable symmetry and distribute the guides evenly. We don't need too many guides for now. Let's start with just a few. Use the length brush to extend the guides to the desired length. Let's analyze the reference feather from the parrot's body that we'll be creating. It's quite wide and fluffy at the bottom. So we'll use this feather as a reference, but aim for a less worn appearance. The guides are hard to see, so let's increase their thickness. Take the comb brush and activate symmetry along the x-axis. Begin sculpting the upper guides. According to the reference, they should be short, so we'll shorten them using the length brush. Freeze these guides and move on to the next ones. The top of the feather should be quite wide. Turn on the groom to see the results. Oh, it looks like we have a problem. The ramp is incorrectly set up, causing the strands to grow from the wrong side, resulting in twisting. We'll fix this shortly. Let's first adjust more of the guides to better see how we need to set up the ramp. As suspected, the strands are growing from the wrong side. Let's fix this. Select the ramp in the density map. I'm placing the ramp's texture in the stem material's color so I can clearly see where the white stripe is, indicating where the strands are growing from. As you can see, the white stripe is not where it needs to be. Move the sliders to the correct position and adjust the stripes. Now everything is correct. Our feather is starting to look like a real feather. We see sharp transitions between the guides, which can be smoothed by adding more CV points for both the guides and the strands. Since we'll also be using a noise modifier later, it's better to have more CV points on the strands. Sometimes Maya doesn't always update the CV points automatically, so you might need to do it a few times or restart the scene. But we managed to get it right. Let's continue refining the feather's shape. The feather's shape is still too narrow, so we need to widen it. We probably need more guides now. Create them. The feather was fluffier at the bottom, so we'll need a noise modifier for that. Create the noise. And place a ramp in the noise mask. Since our UV coordinates are on a single axis, it's easy to control the noise area using the ramp, and we only need it at the bottom of the feather. Make the necessary noise adjustments. We also need to distribute the guides on a single plane. From the top view, let's gather them all together first. However, to give our texture a certain specular highlight and make it look more three-dimensional during rendering, we'll add some curvature. Now, as you can see, we have a nice specular strip and the feather no longer looks flat. We probably need more guides at the bottom to increase the fluffiness. The overall shape of the feather is ready. Now, we need to add some natural randomness. Apply a clump modifier. We don't need a strong clump effect, just a slight one. Adjust the settings as needed. Also, apply a general noise modifier to introduce slight randomness to all the strands of the feather. Again, adjust the settings, keeping the frequency very low. Here's the feather we've created. Let's save the scene. Now, of course, we need to create the texture. As you remember, the feathers we created had 4 different UV islands that were distributed randomly across all the feathers. To ensure our feathers don't all look the same, we'll need to create 4 different textures. These can vary in both color and shape. I'll now walk you through the basics of creating just one texture. Once you understand the principle, I think you'll be able to create the other variations on your own. You can render in any engine you prefer, but in this video, I'll demonstrate using V-Ray. This renderer processes grooming faster, but you can also use other renderers. At the moment, our scene doesn't have any light sources, and it's dark. Let's create a light dome to provide diffuse lighting from all directions. We'll assign a material to the base and activate viewport subdivision rendering to make sure our base renders smoothly. Adjust the material settings accordingly. Next, let's assign a material to the groom. In the color slot, add a ramp. As you can see, the ramp is distributed according to the UV coordinates of the object the groom is attached to. This is useful, but we also need the ability to control the color from the root to the tip of the hairs. For this, we need to use a hair sampler node, which we'll create. Remove the coordinates from the ramp used for color and connect the distance along strand output from the hair sampler to the input on the ramp. You won't see any changes in Maya's viewport, but you will see them in the render window. As you can see, the hair roots are now black, while the tips are white. With color applied, this effect becomes even more apparent. To create a good normal texture, I'll place a plane behind the feather. Additionally, to avoid having a black outline around the hairs when cutting them out from the alpha channel, I'll make the plane's color the same as the mid-tone of the feather, in this case, green. Based on references, the edges of the chest feathers on a parrot are darker. While the edges of the feathers on the wings and tail are lighter. This is why we needed the hair sampler to achieve this effect. I still want the bottom of the feather to be one color and the top another. To do this, we need to combine 2 ramp textures so that one is nested within the other. I'll create a new ramp, place it in the material's color slot. And insert our ramp, which distributes color along the hair length, into one of the colors of this ramp. I'll make the left color of the ramp a darker, cooler green. Let's see what we've got. To enhance the lighting, we'll add an HDRI texture to the light dome. Here's how our feather looks. We'll rotate the HDRI texture a bit to improve the specular on the feather. To render the normal map, add a bump normal pass. The bump normal works as expected. We also need an alpha channel so that the plane with this material appears as a feather. For this, all we need to do is reduce the out matte opacity value in the surface material applied to the background plane. Let's render our texture one more time. Everything looks good. The alpha layer is working. Now we have the three essential textures we need: color, alpha, and normal map. These are the basics of feather texturing, and the rest depends on your creativity. I can show you the feather textures I used. As you can see, there are variations, including the textures I used for the feathers on the wings and tail. Now, I'll show you how this works in a simplified setup. Here's our model. We apply the material to the feathers. Place our color texture in the material's color slot. And connect the alpha texture to opacity. You won't see transparency in the Maya viewport, but during rendering, you'll see that the feathers display correctly. You can also add our normal map texture to the bump slot. That's all for creating feather textures. Now, it's time to set up feather dynamics for animation. We'll aim to achieve a jiggle effect. So, we have a fully finished parrot, and now we need to add dynamics to its feathers. I've already created a simple skeleton for it. As I mentioned, the client wanted to animate only the head and a bit of the body. I've also created a simple animation for it. We've already made the feathers for the body, and we'll be creating dynamics using Maya Encloth. Activate Encloth in Maya. If we apply Encloth to our feathers that already have a material assigned and fully configured, the following will happen. After selecting FX in the Maya, choose Encloth, create Encloth, and then in the Solver menu, select Create New Solver. Finally, click Create Cloth. As we can see, Encloth has completely erased our material. This is not what we want. Therefore, I prefer to keep the model with Encloth separate from the model that I will render. This means we need two versions of the body feathers. I'll delete all the connections from the feather model and duplicate it to create a new version. We'll name the model we'll render and place it in a separate layer. Do the same with the model that will have the dynamics. Clear the history on both models. Now you can see that both models are not bound to the body and move along with it. First, we need to bind the feather model with dynamics to the body. Go to Maya, select Modeling, then Deform, and choose Proximity Wrap. At the moment, in the Attribute Editor, the selection for the driver is inactive. The driver is the object we want to bind our feathers to. We can only add the driver once it is selected. To ensure the proximity wrap settings don't disappear when selecting a new model, we pin it. Now, select our driver, which is the body model, and click Add Selected as Driver. Let's check. Yes, everything is working as it should. The feathers are bound to the body model, but are only partially controlled by it. This is easy to fix in the settings. We increase the follow scale. Now everything is as needed. We can smooth the effect a bit by adding a smooth modifier. Everything looks good. The feathers are attached. Now we can apply in cloth to our feathers. Go to Maya FX, then in cloth, choose Create in Cloth. In the Solver tab, select Create New Solver and click Create Cloth. Let's check. It doesn't seem like there is any dynamics on the model. We need to change the playback speed from real time to play every frame. Check again. Yes, now our feathers are falling down, which means the dynamics are working. Everything is moving very slowly. To speed up the process, we can completely disable collisions. In this case, collisions are not necessary at all, but this will speed up the simulation. Now the process is faster. Each of our feathers consists of a plane. We need the base of the plane to have no in-cloth dynamics, while the other end of the plane needs the dynamics. If we assign a ramp to the feather material, we'll see that, thanks to our UV coordinates, the ramp is positioned in the right direction. This means we can control the dynamics with it. In the in-cloth properties of our feathers, find Input Mesh Attract and set it to 1, meaning it's fully activated. Now, in theory, all dynamics should be locked. Yes, the feathers behave as if they don't have in-cloth. Now we can go to the Dynamic Properties Maps, find the Input Mesh Attract map, and add our ramp. As you can see, now there is dynamics only on one end, but it seems to be on the wrong end. So, we swap the colors on the ramp, white to black and black to white. Now everything looks as it should, but the dynamics are too strong. We can reduce it. But first, let's lower the space scale and the nucleus to 0.1. I'll set the start time for the dynamics to 110 because that's when the animation is more active and we'll see the result better. This is how strong our dynamics are at the moment. By adjusting the color on our ramp, we can control the strength of the dynamic effect in in-cloth. If we make the color lighter, the dynamics are blocked more strongly. It's already looking pretty good. If I make the color darker, there will be more dynamics. Now we just need to connect the feathers that will render with the feathers that have dynamics. We do the same thing by assigning the proximity wrap modifier. Now our feathers are connected. We don't see the dynamic effect because the time on our nucleus starts not from frame 0, but from frame 110. From frame 110, everything works correctly. Let's slightly increase the dynamics. Now, let's look at our final result. That's it. This lesson is complete. Thank you for watching. Please subscribe to the channel and like the video. I look forward to seeing you in the next video.